Hey, in this video we're going to go through a couple of quadratic formula problems. The good news is after you do this a couple of times, because it's the same thing in the same order every single time, it gets to be the same. So the first thing we are always going to do is we are going to identify what our A, B, and C values are. This is the same A, B, and C value we've been finding the entire time. This is coming from the definition of a quadratic. Then what I would do is over here in this formula, wherever I see an A, I would plug in 1, a B is an 11, and a C is a 12. Or sorry, a C is a 30. Now as I'm doing this, I'll try color coding it this time. One thing to keep in mind is the only place I am going to see anyone mess this up is this first piece. It is always the opposite of whatever our B value is. So in this problem, I have positive 11, it's negative 11. And from here, I'm just going ahead and I am plugging in our various numbers. So there's my first step. The next step is I am going to find the determinant. That is this piece right here, and it tells us how many answers we have. And what I see here, I'm going to type exactly into my calculator. So I'm going to take 11 squared, and I'm going to subtract 4 times 1 times 30. When I do that, I get 1. And then in the denominator, I'm going to take 2 times 1. Now, as I'm doing this, you're going to notice that I am writing out kind of my answers for each step. We're going to do that to help keep track of what's being done next. My next step is I'm going to find the square root of 1. That's 1. And then to finish this problem, what I'm going to do is it's finally going to get split in 2. One of the times I'm going to add, and one of the times I'm going to subtract. I would take my numerator, and I'm going to add those two numbers together first. Negative 11 plus 1 is negative 10. I would then divide it by 2, and one of my solutions is negative 5. In the bottom, I would do almost the same thing. I would take negative 11 minus 1. I would divide it by 2, and I get my other solution of negative 6. Now, as you're looking at this, it's going kind of quick. Again, I find the discriminant. I think I said determinant earlier. I mean discriminant. It's this thing under the radical. How I do that was I typed exactly what I see into my calculator. Once I do that, I square root that number. If it's a whole number, we move on, like in this problem, and if it's not, I reduce the radical. I have a couple more example problems, and we're just going to go through them just to make sure that you see every possible thing. My next example problem is this guy. Again, the first thing I am going to do is I'm going to identify my A, B, and C values. And from there, I'm going to plug them into the formula. So the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Again, the first thing I'm going to do is I'm going to find my discriminant. I'm still going to have negative 5 plus or minus the square root of something. And on my calculator, I'm going to take 5 squared minus 4 times negative 3 times 5. All right, doing all that gets me 75. And this is going to be over negative 6. Now, just like before, I'm going to try to square root this. When I do that, I get a decimal. So what that means is I need to reduce this decimal. This is where we have our chart, and we're trying to find which of the perfect squares 75 or can divide into 75. So I would try 64. I'd get a decimal. I'd try 49 and 36. I'd get decimals. When I get to 25, that is going to work. 75 can be written as the square root of 25 times the square root of 3. I square root 25, and that gives me 5 square roots of 3. So to continue this without having a god-awful decimal, I would go like that. Now, for this problem right here, I would be done. I would be done because my numbers are 5 and a 6. I could reduce those negatives here, which would probably be the best thing to do. I have a negative in my numerator and denominator, and a negative divided by a negative would be a positive. But let's talk about if this problem was a little bit different. Let's say, for example, I switched those numbers around. Now, in my numerator, nothing would change, but in my denominator, this would become a negative 10. If this happened, and the reason why we're bringing this up is because I can reduce this fraction. I can look at that and go, oh, hey, I have numbers that go into each other. Namely, 10 can be rewritten as 5 and 2, and those 5s are 5 and 1. I could divide every number that I see that is not under the square root sign by 5. When I do this, I would have 1 plus or minus 1 square root of 3 all over 2. What I did was I divided every number by negative 5. I'm throwing that negative sign in there just to get rid of my negative in the denominator. Now, this is kind of what the perfect answer would look like. I'm reducing as much as possible. In this problem, you're seeing me reduce both the numbers on the outside that are not radicals and reducing the radical as well. Out of all the quadratic formula problems we have, this one is the hardest. And the only reason why it's difficult is because we're bringing up stuff from previous units, such as reducing a radical or, reducing this as a fraction to make our answer as pretty as possible. I have one more example. Again, my first step would be to plug in those numbers into my formula. Again, my first step is to find the discriminant. And when I do 1 squared minus 4 times 4 times 12, I get a negative number. I would stop here, and I would just call this no real solutions. All right, now, as you're going through this, it's like a fraction of the time that I take for other things, and I'm saying I've just done 3 examples. The reason for this is that the quadratic formula isn't particularly interesting or even really that hard. All we are doing is plugging things into our calculator, and sometimes we have to reduce things a little bit more. As you are practicing these, if you do it a couple of times, because it's the same thing in the same order, it's find the discriminant and then start reducing. It makes these problems pretty basic. In addition, this is something where the better your number sense is, the easier it's going to be for you. As you are practicing these, please be sure to let me know if you have any questions. Otherwise, here are some examples for how we can use the quadratic formula to solve a quadratic.